Hello, this talk is called The Promised Land. It's not actually about promises, so if you were hoping for asynchronous programming, you may be disappointed. What it is about upgrading legacy code bases. Crowd goes wild. We're here, we're learning a lot about the future of JavaScript, or the exciting world to develop JavaScript that we are in now. JavaScript's cool again. We're making brains out of JavaScript, and we're talking to JavaScript, and we're doing all sorts of, we have a cornucopia of these JavaScript libraries. But at the end of the day, we're going to go home, and most of us are not going to have the pleasure to work just on fully modern code bases all the time. Like almost always, we're supporting some sort of code base that was written maybe before these technologies that we want to use to make ourselves faster came out or were incorporated into our development practices. And so this talk is sort of about a couple approaches that I've worked on this a lot in the last couple of years, kind of upgrading some of the code bases where I work, and trying to figure out how to do that without making the normal trade-offs that you have to make around maybe slowing down feature development or making the user experience worse during the upgrade. And so hopefully there's something relevant in here for those of you who also have to deal with legacy code. Some information about myself. My name is Cosmo. That's my website. It is HTTPS. I don't know where the HTTP shamer went, but it's HTTPS. So there you go. It has my GitHub and my Twitter and my email and my whatever other information you need. So I love to talk about this stuff. Please feel free to get in touch if you have any questions after this conference. I'm in town from San Francisco, where I work at a company called Clever that works kind of educational data company. So what Clever does is not incredibly relevant, but I'll touch on it really quickly just because context can hurt, and it'll also make our recruiting team happy. We're always hiring engineers, and San Francisco is a great place to work. Clever connects schools with the apps that they use. A lot of schools buy a lot of software. A lot of schools have kind of disparate data and disparate systems set up to manage their staff and their kids. And setting that all up and making it work well together and making it easy for kids to log in is very difficult. And so Clever takes the data from the left. We kind of incorporate it, and we help the schools manage it. And then we have sort of a modern suite of APIs that applications like Khan Academy can consume from. And so that's our product at a high level. And we build it and we ship it. And then people without fail say, OK, so my data goes in and my data goes out. But how does it work? Like, what is happening in the middle? How do I configure it? How do I edit it? And so we built something else that I think almost every company has in some form or another, which is some sort of account dashboard that you can kind of log into. You can manage your settings. You can add teammates. In our case, you can kind of set up the applications you want your schools to use and whatnot. This is a screenshot we took. The oldest one I could find is about from 2013, I think. The product itself is older than that, but I couldn't find any screenshots. And so we built it back about, I guess now, 6 years ago. And we used the technologies that we wanted to use at the time, which were CoffeeScript, Express app on the back end, doing mostly server-side rendering with a little bit of jQuery on the front end for like drop-downs and stuff. But in general, kind of back-end server-side rendered app. And it's pretty minimal UI. There's a couple different pages here. And over the last 6 years, that app has grown to be more complex. We now have, this is a more recent screenshot, we now have a couple hundred pages. We have about 100 pages, a couple hundred routes. So a page is like /settings, and then you have a post and a get and a delete and a couple different routes powering that page. And so I think we're at about 100 pages and about 300 to 400 routes on this. And over that time period, development was not always smooth. We had had patterns that we liked back then that did not grow well over time. In general, I think code bases trend towards being more complex, obviously, and these kind of patterns, especially in these kind of web apps, where you have a lot of complex user interactions and you're pulling data from a lot of disparate sources, tend to get complex pretty quickly. at one point, kind of at the the breaking point, if you will, this is the home page, and the home page was loading the same piece of data from the same internal service 7 different times just to render the home page. And that, you're like, why would you ever do that? And it's a good question. It is a combination of, one, just the code's complex enough that we don't even realize that you're loading data from a bunch of different places, and 2, even if you know you're kind of duplicating a call or something, it's structured in such a way that it's very hard to pass the data from where you're loading it to somewhere else that needs it. And so we were seeing page load times that were far above what we wanted, and from the hundreds of milliseconds to seconds in some cases to load just some pages. It got pretty bad. And at the same time, I don't know if you've heard of, I guess, Hofstadter's law. I don't know exactly how you pronounce this person's name, but it's basically software development always takes longer than you expect, even when you expect it to take longer than you expect. I think this is sort of a universal truth. And around the same time where we started to hit this kind of breaking point with page load times and complexity, we had engineers and sprint product managers in sprint plannings start to throw around what they called the clever dashboard law. And this whole story is true, but also this explicitly is a true law that was written down internally. It's basically the dashboard development always takes twice as long as you expect, even when you take into account both Hofstadter's law and the dashboard law. And so suddenly we had you'd be like a sprint task to add a button to this page, something pretty simple. And the engineers were doing geometric progressions just to figure out how many days it was going to take to add a button to a page. Depending kind of the dev practices where you come from, maybe adding a button to a page is normally takes a couple days or something. For us, this was an extreme outlier on the high end. Most of our code bases we ship to production multiple times a day. There's always feature development in progress, and something simple like a copy change or adding a button or something should have been an hour change, not a multiple day change. And so we said this is untenable. We have this is a bad user experience, a bad developer experience, and we need to kind of pay down this tech debt once and for all. And so we set out some goals, and there's a lot of kind of goals that were internal, move off of this legacy data service or whatever. But the ones that I think are relevant to this talk, we wanted it to be a single-page web app. We started to build a lot more kind of complex UIs with micro interactions, where you're dragging sliders and you're interacting with filters and stuff, and that would just not be a good user experience as a server-side rendered app. To make a single-page web app, we wanted to use React and Redux. There's a bajillion frameworks. You can use whatever you want. This talk isn't even very specific to React and Redux, so the code you will see is React code. But React and Redux is something that we used in other places internally. We had that kind of institutional knowledge, and so it was what we wanted to use for our main web app. TypeScript is sort of similar. I have no, use Babel or CoffeeScript or any of these other kind of transpiled languages. We were excited for TypeScript for 2 reasons. We wanted to use async and await, the modern asynchronous programming. And at the time, it wasn't ratified as part of an ES spec, so we needed a down compiler. And 2, we were excited as our team grew out to start adding more strong types into our development so that we could have kind of a maintainable code base at scale. And so TypeScript was sort of an obvious choice for that. And then overall, we wanted a kind of stateless backend API so we could avoid this 7 data loaded 7 times. We have these easily testable, very fast API endpoints that we can load into Redux and not have to worry about duplicate loads and whatnot. So those were sort of the high-end technical goals that we knew from the beginning as when we set out. And then we also had sort of a more meta goal, which I think is maybe, in my mind, one of the more important goals. So I want to kind of explicitly highlight it, which is we need to make it easy for engineers to do the right thing and hard for them to do the wrong thing. And the reason for this is very simple. It's we did not end up in this tech debt state because we just ignored the problem for 5 years. It was, we would on multiple occasions say, okay, let's spend a couple of weeks paying down some tech debt. Let's convert this page to a web app, a React app, so we can improve some of this super complex jQuery code, or let's convert some CoffeeScript files to be JavaScript files, so we can start moving off of CoffeeScript. And we'd send an engineer or 2, and we'd maybe convert, let's say, 50 CoffeeScript files over, which is pretty good. But the 4 or 5 other engineers, on other teams working on other features, would just do what they knew how to do. Do what they'd go in and copy and paste and look at existing patterns. And so in the 2 weeks it took to pay down that tech debt, we'd get 60 new files. So we ended up with just at the end of the day 10 CoffeeScript files because the easiest way to develop was the existing patterns, and the existing patterns were not what we wanted. So it was like rolling a boulder up a hill. And so we said, OK, we need to avoid this kind of, you're working on improving it and you're working on just making it worse. Like, how do we sort of do a once and for all, move everyone over to the right patterns? And the answer was easy. It was a rewrite. We'll just pause feature development for a couple months, rewrite our main app. Obviously, rewrites will always come in at under the time allotment. They won't ever take longer than you expect. That should be a simple choice, right? And so, the engineers advocated, me being one of them, advocated pretty aggressively that if we did not do some sort of rewrite, we would not be able to achieve these goals. And management was not having it for obvious reasons. And so we end up with this sort of final kind of important goal, which is we need to maintain feature development velocity. Whatever we do, we can't sacrifice that. And that's really the crux of what I want to talk about. There we go. We have sort of three approaches that we tried sort of sequentially. DOM Snatcher, then we came DOM Snatcher After Dark, then we came D2. The D2 is the one that we found the most success with and sort of used successfully to complete this project. However, I want to talk about them all because for a couple of reasons. One is they built off of each other in kind of illustrative ways, I think. Talking about the trade-offs, it was, I think, very important. And two, just talking to some of you folks, I know the Shopify team I was talking to has done something similar internally. And I've heard from other companies as well that kind of a mixture of these three attempts. And so I want to talk about them all because I think depending on what your goals are as a company and depending what the situations you're working in, then any of these could be sort of applicable. And again, building off of each other is a good way to kind of show the pros and the cons of each approach. So without further ado, and I know everyone's wondering why is a project called DOM Snatcher? That's a good question. Clever just likes fun names for internal projects. Talking about legacy code upgrading is a lot more fun when you can just say DOM Snatcher a bunch. And so I think we even have the dashboard. Someone photoshopped that in. So it's like a very, I was very happy with the DOM Snatcher branding for this. DOM Snatcher is a fairly easy concept at a high level. It comes from the idea of if the right way to do things are to make new pages or to create React component, like a front-end React page, but the entire app, the kind of UI Chrome of the app, the orange in this example, the sidebar and the header, if that is all still being back-end rendered, the effort to create a new React page is very difficult. You have to first create a back-end route. You have to create a back-end template with no content in it. The back-end template has to include React in the script. React has to then attach itself to the DOM. You then have to write your React app. That's like 4 extra steps where people, if you're just putting a button on a page, you're just going to write a back-end route, put a button on it, call it a day. Like you're not going to try to bother to use React, even if we want people to move towards this fully front-end front-end UI. And so if we're going to make it easy to people to develop React apps, we need to we need that kind of common UI Chrome to be React. So it's easier to create new React pages as opposed to creating backend pages being easier. So yeah, again, basically we're trying to figure out a way to make this the UI Chrome be React. And so for a front-end web app, your HTML might look something like this. There's obviously a bunch of analytics and meta tags and stuff that aren't here. But you have this the server returns just an empty div. You include your script, and the script then sets up React and fills the div out with a bunch of content. But if you have something like this is a server-side rendered page. This is a server-side rendered page. You're going to have to trust me, and also you can tell because it looks kind of funky. If you have a server-side rendered page, then your HTML might look something more like this, where you still have the React app here, maybe not. For this DOM Snatcher world, you need to. And then you have this content div, which is like all the server-side rendered content. You may also have some scripts that are relevant for this page. And we need to find some way to kind of suck that content, snatch that content out of the DOM, and throw it into the React app so it can be part of the React tree, which is where the name DOM Snatcher comes from. To do that, This is now, I think, the first piece of React-specific code. Again, all of this code is from our Git history, so this is like, I wasn't trying to create fake code for this. But if you don't use React, if you use something else, you can, hopefully it's simple enough that you can kind of interpolate it in your mind. This is React Router. It's how you set up, with React, how you set up front-end routes. So we're saying, OK, we have these two routes that are kind of modern, new, fully front-end components. We have the home page, and we have this account settings page. And all of these routes will be wrapped with that UI Chrome, that kind of header and sidebar. And then we can say for all the other routes, for the routes that are handled by the server, or rendered by the server, use DOM Snatcher to snatch that out of the DOM and throw it into the React tree. And so then DOM Snatcher, and hopefully you can look at this. We're going to see it a little bit smaller as the slides get more complex. So so far, so good. DOM Snatcher is a pretty simple component. When it enters the page, as it mounts, it looks for that content div that has the server-side rendered content in it. It snatches it out by grabbing the inner HTML and then removing the div from the page. And then it drops the inner HTML into the component itself. And so now wherever we put this DOM Snatcher component in our React app, it will look for it will basically render the server-side rendered content again. There's a little bit of nuance here where I think you need to prevent it from re-rendering, because if it re-renders, the content will no longer exist and whatnot. Dangerously set inner HTML is a funny name if you've not seen it before, but it is a React API for basically bypassing all of the normal escaping that React does, because we trust this HTML, and it will just basically be the equivalent to being set inner HTML. And so this now, we can put this component wherever we want. It will, again, grab the server-side rendered content and drop it into the React app. So again, to this example, we can have the React UI, and then this can be rendered by the server, get snatched via DOM Snatcher, and dropped into the React tree. And so if I then click on the home page or something, I now have a fully Reactified app. And overall, it accomplishes the goal. It makes it very easy to create new pages, and all the server-side pages work with almost no changes to them, which is great. The downside that we saw with this is it mixes new and old patterns. So we saw a lot of engineers, the engineers who were very excited about this work and were excited about the kind of upgrade process and kind of were very aware of what was happening. This was great for them. They were like, this is great. I can write all my new pages in React. I'm very happy. I'm more productive, et cetera. And all the engineers who sort of just wanted to just build their features and not pay attention to all this minutia around upgrades, they would still go in and just, again, do whatever they knew best, which is whatever the existing patterns were in many cases. And sometimes it would actually be even worse. People would spend the time to build new React pages correctly, but then be calling out to APIs that were still the legacy code base and still maybe hitting internal data services in the wrong way. So by mixing these new and old patterns, we were able to, with very low effort, build a fully React app with the UI Chrome and make it much easier to develop the right way. But we didn't have enough of the carrot was there, but we didn't have enough of the stick to move people over. And so the upgrade process kind of stayed a little stagnant. And so we said, OK, let's make some upgrades. And DOM Snatcher After Dark, another just funny name. It basically stemmed from the fact that we're trying to do some weird stuff here. DOM Snatcher was already kind of weird. Anytime you write dangerously set anything, it's like, OK, what's happening here? But DOM Snatcher After Dark gets weirder. And this is sort of stemming from the idea of let's make a really hard separation between the new and the old code base. So let's build a new code base with green grass and birds are singing and everyone's happy. And then we'll kind of segment off this old code base off into the corner somewhere. And we can use that code base. So let's, again, write a new dashboard from the ground up. And then we can convert the old dashboard into more of an API. So instead of being a web app with returns HTML and has sessions and whatnot, it's more of an API that returns the content and the scripts and the information, maybe the title, the information needed to render the page as a front-end web app. But the only thing the user is interacting with is our new modern front-end web app. So it's this translation middleware to kind of upgrade this legacy code base into a fully front-end web app with no page reloads, which is the dream, I think. So architecture diagram because if we're just really hammering it in. So the user is interacting with our new dashboard, no page reloads, fully front-end web app. There's like loading spinners and skeleton states, and everyone's happy. The new dashboard will sometimes call out to this kind of old dashboard or the old dashboard API, which we run kind of within our development VPC, not publicly accessible. And the old dashboard says, OK, this page has this content and this title and whatnot. So at a high level, this is like fairly straightforward, I think. The implementation, the devil's in the details, if you will. The first step is our new dashboard needs to have an API endpoint that will kind of fetch content from our legacy dashboard. And so this is now backend code. This is Express. If you don't use Node or Express, it's hopefully fairly straightforward regardless. We're basically saying all requests to this route, take the URL property out of that, pipe the request through to the old dashboard with the URL using whatever method and whatnot, add an authorization header that basically says, give me the content for this user, and then pipe whatever we get back to the front end, to the user. And so then our client code is pretty similar. Actually, I think exactly the same, except it says after dark there. So we still have the UI Chrome all in React. We have the new React pages that we've already written. And then all other pages we're going to handle with DOM snatcher after dark, which will then hit the proxy endpoint and figure out what's on the back end. DOM snatcher after dark becomes more complex because we actually have to track loading and a bunch of other states. So when we first initialize, we say loading is true. And when loading in the render function, we'll return a loading indicator, so the user just sees like a spinner. Then when we're about to mount, we take the URL, we proxy it through to the legacy proxy. We get back the scripts and the inner HTML from the legacy proxy. And then we can store those in the state, turn loading to false, and render again by dumping the inner HTML into the DOM. And so this looks fairly similar so far to DOM snatcher, only we're kind of doing an asynchronous load, except there's this to do, which is once the content is loaded, we have to actually process it and maybe attach the event handlers to the HTML for the scripts that we loaded. We also have to update all the URLs because now everything has to go through the legacy proxy. This to do this is sort of one of these situations where we have the two circles so far, and there's a lot left before the rest of the owl is done. And so I'll dive into a little bit of that, but there's a lot of complexity here, so I don't want to kind of monopolize the time. The first thing we need to do, and this is a real to-do list I found in my Apple Notes app, actually. So again, all of this is straight out of history books. First thing we need to do is we need to update the static asset URLs. So now images have to be fetched from legacy proxy, blah, blah, blah. And so luckily, if you use a CDN or something, this is actually very easy because it wouldn't have to be proxied, but we didn't use a CDN. So luckily, Webpack helps us here. I don't even know if this is the up-to-date Webpack config because they change the format now and then. This is a while ago. But if you have an output declaration that looks something like this, we were just able to add this API legacy proxy in, which basically said prefix all of the include paths with that, which worked. That was 90% of the way there. We had to do some text replacing here and there and whatnot. But Webpack kind of really helped us out with this one. We need to actually load the scripts, right? So we got the scripts back from the API. So this page requires these JavaScript files. We actually need to load them into the page. That, again, is actually pretty straightforward, luckily. We can just say, for each of the scripts, create an element, set the URL, and append it. There's some, again, more nuance here. We wanted to track whether or not the scripts were loaded and not show the loading indicator or keep showing the loading indicator until the scripts were loaded and whatnot. But again, this is 90% of the way there. This is also not very React. This is from a React world, this looks totally weird. It's why aren't you rendering or whatever? But because we're trying to attach these scripts are sort of don't exist in the React world, so we have to do this. We need to convert all the links to be React router links, so they instead of doing a hard page reload when you click on them, they do kind of push state kind of thing. Again, fairly straightforward for the base case, where you can do sort of find the element. Once we've rendered the HTML into the element, we can find the element. We can find all the links in the element. For each of the links, we can set an on-click handler and use that to kind of push state as opposed to doing a hard page reload. We don't want to overwrite existing on-click handlers for analytics or anything. So probably would actually want to check for existing on-click handlers and call them and then do this. But again, the base case is fairly straightforward. And then the final one, I think probably the most complex, is that form submission needs to be Ajaxified. So all the form submission needs to go through that legacy proxy API endpoint, and then we need to re-render the content again when we get back. Still, like, not super complex for the base case. You have this, you can set an on-submit handler on all the forms, pull out the serialized data and the action URL and the method, set loading to true so we get the loading indicator again, make a fetch through to the legacy proxy, with the URL and the data, and then whatever we get back, whatever API response we get back from this like API-ified dashboard, we can re-render that into the component. And again, like there's a lot of nuance, especially with forms, but this is like a 90% case. And you might be saying, like Cosmo, this is interesting, but we talked about the 90% case for all of these. Like the 10% is the interesting stuff, right? Like that's where the complexity lies in an approach like this, which is 100% true. And that's something that we realized as we built this, which is basically the 90%, which is basically the code that I showed, was pretty easy. We knocked it down in about a day or two of that kind of local experimentation. But the last 10%, like making sure all the pages worked exactly, it was like an infinite amount of work, I think, in our case. We'd roll it out. We'd be like, oh, like most of this works except this one page. If you do this one thing with this one attribute or something, wouldn't work. And so we were always kind of tracking down custom issues and fixing like little hacks. And we realized that I think this approach is very promising, but when we have as much kind of varied practices on the back end, like we had some React apps running in a legacy code base, we had some jQuery, we had some just random practices people threw in as hacks. Like without enough standardization there, it became fairly difficult to make sure this was something that we could roll out and be confident in for a serious amount of time. And so I'm actually very excited about this approach. I think it is the best user experience if you can get it right. But for us, it was very difficult. I think if we had something more some standard expectations around like what the old pages were doing, maybe we were using like a form builder or like a Rails or something where we had a little bit more prescriptive output, this could be very promising. But without that, it became sort of this trudge through tracking down random issues and fixing them with fixing hacks with other hacks. And the other downside of this was it made it very difficult to develop in the legacy code base, which originally was a pro, right? We talked originally like we want to make it easy for developers to do the right thing, hard for them to do the wrong thing. But when you convert a web app where people are used to like logging in and inspecting element and seeing the content and maybe changing copy or whatnot to an API where you have to use Postman or like curl to interact with, that was almost too difficult to develop. We'd get like little tickets like, hey, can we change this copy to not have a spelling error in it? And it's like, yes, we should do that. No, we shouldn't port the whole page over to the new app just to do that. But it's going to be even harder than it was before because we've sort of API-ified this web app. And so I'm very excited about this approach, but it has some pretty serious trade-offs, and they helped us inform the final approach, which is ironically the only one without a funny name. D2 internally just is dashboard 2. I don't know why we didn't just call it dashboard 2, but that's lost to the sands of time. And also, I was the one who named it, so I really have no excuse. But D2 is sort of the Goldilocks of these three methods. We would still write a new dashboard from the ground up, but instead of kind of trying to proxy through and doing this upgrade middleware, this upgrade layer, this kind of weird DOM signature after dark approach, we will just proxy request to the old dashboard, which we run alongside it. As part of this, one of the benefits of that is we made it very easy to develop the old dashboard. There was almost no changes that were required. And so going back to making it kind of like discouraging people from doing the wrong thing, one of the things that came out of this project is we actually kind of rebranded the old dashboard internally, the GitHub repo and everything, to be called Trashboard. And it's sort of a funny, it's a funny name. People see it and they laugh. But it also, I think, actually there's actually sort of an important change, because if you're a new engineer and you just joined and someone tells you, go make this change in the dashboard, so you go into GitHub and you search for dashboard and you see two repos, you see D2, like subtitle, like the future of dashboard development, and you see Trashboard, subtitle, like literal trash. It's pretty clear which one you probably should be working on. And so kind of doing this rebranding was not so much a technical guide, like a rail, but more of a kind of like a soft like marketing rail to basically move people away from bad patterns. And it's been very effective, I think. It's a very catchy name, and this GIF is just a good GIF. So the general idea here, again, is like, so the user will be talking to the new dashboard, and when they're talking to the new dashboard, no page reloads. But when they're talking to Trashboard, instead of trying to do all this like upgrading and whatnot, we will just directly proxy them through. So if, for example, you go to a Trashboard route, maybe you're not logged into Trashboard yet, the Trashboard will just has no idea it's even being proxied, so it just returns the login page HTML, and the user logs in, hits submit, goes again to the Trashboard. The Trashboard then renders whatever content it expects. If you click to a new page, you see the new content. It's actually a fairly straightforward approach, as you'll see, and the benefits are fairly high. The only downside here is that you still get hard page reloads when you're clicking around the Trashboard. The Trashboard doesn't feel like a single page web app, which is not a downgrade to the user experience, but it is a downgrade from the DOM snatcher experience. That was a trade-off that we did kind of explicitly make here. And the core code for this is just this giant file, which we call Trashboard routes, because what else would we call it? And this is very much truncated to fit in the slides. I think in reality, again, it's like 300 to 400 lines. And it's just a list of all the routes the Trashboard handles. And then we were commenting them out as we ported them over. So this is a screenshot, again, truncated from like the very first Trashboard route file. And so basically the only two URLs here that the new dashboard's handling are the root URL and /school. Any other URL you went to would just get directly proxied through the Trashboard. But if you went to the homepage URL, which is the one that people went to the most, you'd see the new code base that felt more snappy. And so the server-side code is pretty much very similar to the kind of legacy proxy endpoint, although now instead of setting up an API endpoint, we just were able to set up direct proxy requests. So like for each of those Trashboard URLs, for each of these, just proxy through proxy them through verbatim. We aren't setting any auth headers along, none of that. We're just proxying them through directly. You can see trashboard.internal.clever.com is sort of the internal URL. Again, kind of really hammering that Trashboard branding. We also have to proxy through static assets, like images and style sheets and stuff. And then after we do all that, we can set up the kind of modern API endpoints, the stateless API endpoints that power the front-end web app. So that's what this function does. I think that we nested them all under /API, so they wouldn't conflict with any of these Trashboard routes. But if you have like more varied URL schemes, you might have to nest it as like something more unique so that there's no URL conflicts. That's the only thing you run into here, is that you can't have URL conflicts with the Trashboard routes. And the front-end code for this becomes very, very straightforward. It does the same kind of React UI, setting up the home page and the account settings page. And now we've done away with all the DOM snatching. We've done away with any complexity. The catch-all component's very simple. It's barely more than a 404 page. The catch-all says, OK, if the URL you are visiting is a Trashboard route, do a hard page reload. Just do a window page reload, which will trigger a request to the server. The server will then Trashboard proxy it through, and you get whatever the Trashboard sees there. So the user, and it doesn't feel like a reload to the user. It just feels like a navigation, because the user's clicking around a single page web app, no reloads. They click on a link that goes to the Trashboard. They do an actual navigation, but there's not like you don't see like a flash or anything, because it's just triggering a real request to the server. And if it's not a Trashboard route, simple, just render the not found page. I actually think probably this code needed to exist in the DOM snatcher components as well. I'm not sure where that went. But anyways, render a not found page and call it a day. And so this is like probably the simplest code-wise of all the approaches. It is also the one that worked the best. One, it required no changes to the existing code base, which is a little bit of a pro, is certainly a pro. It's a little bit of a con, again, pushing people to do the right thing. But we found that just kind of like by encouraging it via Git code reviews and the kind of internal branding of Trashboard, we didn't actually see, and just also the like really strong carrot of people want to use new technologies if it's easy. We actually found that we didn't have as many of the problems with people kind of like defaulting to doing the wrong approach like we did with the original DOM snatcher attempt. It allowed the whole team to contribute to upgrading pages. You didn't have to have a kind of context around how this like weird API middle layer worked or whatever. It's like you get a task, you want to write a new page, you just write a new page and comment some lines out in the trashboard, trashboard routes file, and call it a day. I try to pull some data. This is a little bit difficult just because the Git histories is there's been a lot since then, but I think roughly 30 to 50% of our team has contributed to upgrading pages, which is we're pretty happy with. Our Orange team is about 50 people, so that's a fair number of people who have worked on this project in one way or another. With his approach, I think it's sort of undeniable that feature development speed can only possibly increase because there are no changes to the legacy code base. The worst that could happen is that feature development speed stayed the same because the legacy code base is sort of the bottom bar. And by introducing this kind of modern code base, if feature development speed if we haven't at least given the option for development speed to increase, there's something very wrong with the goals that we set out to do, because the whole idea of this modern code base is that feature development speed should be faster on it. And in fact, this D2 repo has had, I think, the most builds in our CI tool of any of our repos since it rolled out. Other repos have been around longer and have had fewer builds. So this is like a very definitive metric that says that is the case, that feature development speed has definitely increased. And so overall, 3 approaches. You should sort of like pick and choose from them as you need. I think I have definitely talked to some people yesterday and at happy hour that sound like they were kind of doing some of these approaches, and I'd love to get more details on kind of the pros and the cons you see, and maybe if you have unique insights that you are interested in sharing, because I think, like I say, these are the approaches that we tried, and you've now heard about them in depth. But I think again, it's kind of a spectrum, and you can pick and choose parts as you need. I think that in general, the things that allowed us to get to the promised land, and I think that's kind of the main takeaways that I would have, is make it so there's a clear right path. This goes back to, again, making sure the engineers, it's easier for them to do the right thing than the wrong thing. So yeah, make sure there's a clear right path so that people can follow. In general, this process can be done as slowly or as quickly as you need. We really, one of our product weaknesses we thought was our account dashboard, and so we wanted to get this done as quickly as possible. We kind of maybe invested more into porting pages over than we would if we were happy with the product quality of our existing code base. I know I was talking to someone yesterday, I forget who, I'm sorry, who was saying like they're going to have they're doing some sort of similar kind of approach, and they're going to have it around, they think, forever. So this is sort of again. Whatever you do, having that kind of flexibility to do as quickly or as slow as you want is nice. If you have sort of if you're trying to do a hard rewrite or something, you're really under the gun, and you'll probably make trade-offs you don't want to make. Providing a carrot and the stick. The carrot is almost always going to be kind of the modern development practices. The stick can change. Like and after Dom's Not After Dark, the stick was this API Frankenstein repo is very hard to develop on. The stick can be you're not developing on a repo with trash in the name. The stick could be code reviews or whatever. That's sort of something that I think is dependent on the org and kind of your goals. But giving kind of a carrot and the stick to move people over is important. And then finally, it can be as easy as starting with a proxy and a URL list. I think you could probably we did the D2 approach like kind of as you saw, but you could probably do it with like an nginx config if that was more natural for your infrastructure. I think in simplest cases, this could be something that you spin up in a couple days, or depending on kind of the context. And so it's not like try and do this kind of giant upgrade does not have to be necessarily a super complex project, depending on how you approach it. And so overall, that's my talk. My Cosmo Wolfe. You can visit my website or email me or tweet me. It's all there. I would love to talk about this. If you have any questions or any thoughts, because I think it's super cool. Thank you.